All right, Unit 3, Day 2, we're going to do some graphing with quadratic functions in standard form. That's different. We did vertex form yesterday. If you remember, here's vertex form, and the h and the k, those are the coordinates of the vertex, and then the a could vertically stretch or shrink it. But if you actually were to multiply this out, distribute the a, and then add k, you'd get your standard form. Okay, so the standard form is kind of the definition of a quadratic function anyway. Ax squared plus bx plus c. Our learning targets up here then are we're going to use the standard form, and we're going to find essential properties of the graph and also find the zeros given in standard form if we're given this. Yesterday, a lot of the information was right there for you, like h and k, those are the coordinates of the vertex. But in standard form, it's there, it's just hidden from you. So we had to do a little bit of work to find it. And notice here, this is kind of cool, that a and that a, those are the same. Notice there's no b or c in here. That's because this number and that number are not the same thing as these numbers in any way. So this c, you will not be able to find that in here unless you put it in standard form, then you'll find it. But this a and that a are the same number. So some properties here. So the same thing as yesterday. If a is positive, the function is considered positive, and the parabola opens up. If a is less than 0 or negative, is considered a negative function, and the parabola will open down. Just like we said yesterday, positive, smiley face, negative, frowny face, or if you have any other fun way to remember, go ahead and do that. Now, yesterday, the h was the x-coordinate of the vertex, which was also the axis of symmetry. So x equals h was the axis of symmetry. Today, not so easy to do that. For this one, we need a slightly different formula. It's like we told you, it's in there, it's just hidden. If you take negative b over 2a, that resulting number, that will be the axis of symmetry. So x equals that, and that'll also be the x-coordinate of the vertex. So that stays true. The axis of symmetry, that value is also the x-coordinate of the vertex. And then the vertex is going to be negative b over 2a, comma, whatever you get when you plug in negative b over 2a. So this is just the y value when you plug in that x. It's just notation for saying plug it into the function to find the y value. So not as easy, not as quick to find as in vertex form, but it's still possible. Then the last thing that's super helpful that we didn't have in vertex form, you couldn't find this in vertex form, was the y-intercept. The y-intercept is actually the coordinate. And remember, if it's on the y-axis, its x-coordinate is 0. So it'll be 0, comma, and then the c value. So whatever this c is right here, that's the y-intercept. Okay, so let's practice with these. So down here, we're going to do some graphing. We need to graph x squared plus 2x plus 3. So first off, what direction will this parabola open? So I need to look back at, well, what's my a? Is my a positive or is my a negative? Because if it's positive, it will be open up. If it's negative, it's going to be open down. Well, the a on this one is a positive 1. So this one is going to open up. To find the axis of symmetry, on this one, I'm going to take negative b over 2a. So that would be the opposite of 2. So negative 2. So b is positive, but I do the opposite, negative 2 over 2 times a, which a is a 1. So I got negative 2 over 2, which means x equals negative 1. So right now I could graph an axis of symmetry at x equals negative 1. To find the vertex then, I know right off the bat it's going to be negative 1 comma something. To find that something, I need to plug it in. So I'm going to take f of negative 1, which is what this says to do right here. F of whatever you get when you take negative b over 2a. So f of negative 1, I'm going to have, and when you plug this in a calculator, put in parentheses. I see a lot of students do this wrong, because if you do a negative times a negative, it should be a positive. But if you put this in a calculator, if you type in negative 1 squared, we know that negative 1 times negative 1 is positive 1. But if I put it in like this, it tells me negative 1. And what it's doing is taking the opposite of 1 squared. Well, 1 squared is 1, the opposite that's negative. What I want to do is take negative 1 squared. And that gives me the right one. So when I type it in, I need to put in parentheses if I'm squaring it. Okay, so negative 1 squared plus 2 times negative 1 plus 3. So negative 1 times negative 1 is 1. 2 times negative 1 is negative 2 plus 3. So this is going to be 2, positive 2. Okay, so at negative 1, positive 2, there's my vertex. Now what is the min or the max here? Now my min or my max is I want to know, first off, is this going to be a minimum or a maximum? Well, we said that it opens up, which means it's going to be a U shape like this. So if it's a U shape and that's the vertex, this is going to be a minimum. When we say minimum, we want the y value. We say the value of the function is the y. So in this case, the minimum value is 2. It comes from there. Okay. Now, what is the y-intercept? So the y-intercept on this guy, if you remember, the y-intercept is the c. So it's going to be 0, comma, I already have the 0 for you, 0, comma, c. So c is 3. So that tells me that I could plot at point 0, 3. So here is my y-intercept. And then I can mirror that over. Remember, this is an axis of symmetry. So anything that's on one side can mirror over to the other side. So if this is 1 unit to the right of the axis of symmetry, put a point 1 unit to the left of the axis of symmetry. Okay, and now we pretty much got our point. Now, if you needed to, if you need one more point, because I know what I get when I plug in -2, -1, and 0. I have those y values, but you could plug in 1 if you wanted just one more point and then mirror it over. Not sure that that's super necessary right now. I mean, it's pretty much, I got enough to plot it. So I got something like this. And there's my graph. Okay. And if you'd like to, maybe pause here and try number 2. Otherwise, I'm going to keep moving along. So this one here, does it open up or open down? That's a positive 2, so this would open up. The axis of symmetry, I'm going to go negative b over 2a. So it'd be negative and then -4. So the opposite of b would be a positive 4 over 2 times a, which is 2. So I got 4 over 4, which is 1. So if I graph the line x equals 1, I've got myself the axis of symmetry, which means the vertex is also 1 comma something. Now if I want to find the y that goes with it, I need to plug that in for x and find what y is paired up with it. So I got 2 times 1 squared minus 4 times 1 plus 5. So 2 times 1 would be 2, minus 4 plus 5. The -2 plus 5 is 3. So now I've got at 1 comma 3 is my vertex. Is this a min or a maximum? Well, it opens up, so it's a U shape, which means this is the lowest the graph ever gets, so this is a minimum. Remember, when we say minimum value, value is y. X tells you when that value happens, but the y is the actual value, so this one has a value of 3. And then the y-intercept is going to be 0, comma, and then what's the c? The c is 5. So at 0, comma 5, I've got a point. And anytime you find a point that's not on the axis of symmetry, you can mirror it over. So I can mirror this guy to the right side over here. Now I've got my U shape. Okay. So let's flip this guy over. And now we're going to look at finding zeros of quadratic functions. So if you look at this guy, when the graph of the function meets the x-axis, we call that, or those points, it depends where it happens, because it could happen once, or it could happen twice, or it could happen never. Like this one hits it twice. Hits it right here, and it hits it right there. We call those the zeros. The reason why we call them the zeros is because that is where the function's value, we say value, we're thinking y's, the y is 0. So on this one, I went left 4, up 0. So 0 is the value. Over here, I went left 8, up 0. So it's called a 0. We also call it an x-intercept. We also call it a solution. There's a lot of names to it, so we'll go over that next few days. We'll talk about all the names we have for it. To find the zeros of a quadratic function, simply plug. What would I plug in for y? Well, I want to know when the y equals 0, so plug 0 in for y. Or you could plug it in for f of x, whatever it's called, so depending on if it's in function notation or not. So let's try to find the zeros of this. Now, if you have a graph, you just look for it. Look for where it crosses the x-axis. Those are your zeros. Now, if I don't have the graph, and I don't have anything to graph it with, you can do this a different way. And this was, it's the whole factoring idea. So I'm going to, first off, plug 0 in for f of x. So now it's going to be 0 equals, sorry, I keep saying 0 like that. It's probably getting annoying, but I'm going to plug 0 in. Let me say it differently. Plug 0 in for f of x and solve. Now, if there's an x squared and an x, we need to factor. Okay, so remember, this is where, if it's a trinomial, we're going to look for two binomials. And I want to know what two numbers multiply to give me 6, but add to give me -5. Okay, so two numbers that multiply to give you a positive 6, but add to give you a -5. So if the product is positive, it means the signs are the same. But if the sum is negative, they're both negative. So it's being -3, -2. And that means, and what if when I multiply these, it equals 0, it means one of them has to be 0. If I said I have two numbers in my head, their product is 0, one of them has to be 0. Okay, I'm sorry again for saying 0 so many times, but one of them has to be 0. So let's just, I don't know which one it is. So what would make this one equal 0? So what would I plug in for x to make x minus 3 equal 0? It would be 3, because 3 minus 3 is 0. And what would I plug in here? I'd plug in 2. Okay, so there's the two intercepts. So this was solving it algebraically. You could also have graphed it. Negative b over 2a has kind of a weird vertex, as it's kind of a fractional vertex, so I want to kind of avoid that. But and you could graph it and look for where it crosses. But zeros are also referred to as x-intercepts, because that's where they cross the x-axis up here. It can be used to, if you're trying to help you graph in standard form, you could use those x-intercepts. Okay. So first off, let's look at this guy. Does this function open up or open down? It's a positive a, so it's open up. Axis of symmetry is negative b over 2a. So this would be a -1 over 2 times 1. So that'd give me x equals -1/2. So somewhere in here is my axis of symmetry. That's also -1/2 is the x coordinate of my vertex. Now let's plug that guy in. If I plug it in, let's see. So I've got -1/2 squared plus -1/2 minus 6. This would be 1/4 minus 1/2 minus 6. Let's see here. So that if I did this, that'd be a -1/4 minus 6, so -6 1/4. Kind of a crazy number here, but that's okay. 3, 5, 6, 4. So somewhere down around here. Is that a min or a max? Again, it's open up, so it's going to be a minimum. The minimum value is -6 1/4. Now, what is the y-intercept? The y-intercept is that number on the end, so 0 and -6. You can mirror that over, and now I'm kind of stuck. There's not a lot of information there. How do I make a u out of that? So I could go back and I could look for the x-intercept on this guy. So I think I should have wrote it. I think at one point I typed this in, but I hit print. Apparently I didn't update. I didn't save it. But I want to know the x-intercepts also. Okay, x-intercepts or zeros. Let's go like this. So I'm gonna factor it. So two numbers that multiply give me a -6. Now to have a negative product, one of them has to be negative. And when I add them, I get a +1. So that sounds like +3 minus 2. Product's -6. Sum is -2. I'm sorry, sum is 1. So if you add those together, you get 1. So that means x equals 2 and -3. So that means that I can go right 2 up 0, or I could go left 3 up 0, and there's a couple of intercepts. So at 2, 0, and at -3, so -1, 2, 3, 0. Now I've got a few more points. Okay, I'm going a little bit faster over here. Again, I'm going to find the x-intercepts / zeros. So does this open up or down? Opens up. Axis of symmetry would be -6 over 2 times 1. It's a -6. So that would be -3. So x equals -3. Now I'm going to plug that in. I got my vertex x coordinate is -3, so I've got -3 squared, put in parentheses, plus 6 times -3 plus 8. So I got 9 minus 18 plus 8. Well, this is -9 plus 8, so that would be -1. So I got my over 3 axis of symmetry. Oh, I went +3. -3, -3, 1. This would be, it's open up, so it's the minimum value is -1. It's the lowest it ever gets. The y-intercept is 8. So at 0, 8. 3, 4, 5, 6, 7, 8. Now notice that is 3 units to the right, so I'm going to go 3 units to the left and mirror it over. That's probably enough to go ahead and graph it just for the fun of it. Let's find the x-intercept. So I'm going to factor this. So let's, we're going to multiply. Let's see. Let's multiply to get 8, add to get 6. So that would be, if it's a positive product, they're the same sign. If it's a positive sum, they're both positive. So +2, +4, that means x equals -2 and -4. So I can go left 2 up 0, or I can go left 4 up 0. Let's see, so 2, 4. So now I've got my U, a little bit better of a U shape. Okay, so hopefully that helps. Remember, please fill out your learning log. Just how do you feel about this? Just the first time through, give it a number or rank it 1 through 4. Think of it as grades. 4 being an A, 3 being a B, 2 being a C, and 1 being a D. How do you feel on this?